Okay, going to be working the solutions here, continuing some solutions in 8-7. Going to start with number 47. So we're asked to estimate the integral from 0 to 1 of x cosine x cubed dx. Yes, okay. So we want to estimate this correct to 3 decimal places, and what we're going to first do is realize we can't do any technique of integration to do this integral easily. It almost looks like we can do a u sub, letting this be u, but the derivative of this is 3x squared. We only have x. If that was an x squared, we would be in business, but we can't. So what we're going to do instead is we're going to rewrite, first of all, the x cosine x cubed in its Maclaurin series. So remember that cosine has Maclaurin series, and these series are found on page 484. And so we know that cosine x is equal to the sum n equals 0 to infinity, negative 1 to the n, times 1 over 2n factorial times x to the 2n. All right, so we're going to use that knowledge to rewrite cosine x cubed. So what we'll do is we'll replace this right here with x cubed. And so this becomes sum n equals 0 to infinity of negative 1 to the n, and then we have 1 over 2n factorial, and then x cubed raised to the 2n. Now at this point, we need to set ourselves up for doing the integration of this, because we have to integrate. So we're going to need to get that x in here, and then we're going to have to make it look like a power series that we can integrate. So what I'll do is I'll push this x in. Let's go ahead and say that that's equal to sum n equals 0 to infinity, negative 1 to the n times 1 over 2n factorial, and then I'll have x, I'm going to go ahead and multiply these to the 6n, but then times the x that comes in from the outside. And when I put these two together, I add their exponents. So this is really just going to become an x to the 6n plus 1. All right, like that. And that's pretty much it. We're ready. We can integrate this now. To integrate this, remember that I'm using the fact that the antiderivative of the sum n equals 0 to infinity of c sub n times x minus a to the n is equal to some constant plus the sum n equals 0 to infinity. The constant will stay, but then I multiply by 1 over n plus 1 x to the, x minus a to the n plus 1. So what I'm going to basically do is take my x term here, and I'm going to add 1 to the power, but then I need to divide through by 1 over whatever that power is. So let me go ahead and do that now. I'll do it here. So I'm just finding the general antiderivative right now. The antiderivative of x cosine x cubed dx is equal to the integral of this. I'm not going to rewrite that, but it would be the integral of this, which is equal to a constant plus the sum n equals 0 to infinity. And then all of this right here is like my c sub n. That's like this part right here. So that's not going to change. So I should have negative 1 to the n times 1 over 2n factorial. And then the important part, I need to scale this out by 1 over whatever this power is plus 1. So 6n plus 1, add 1 to it, you get 6n plus 2. And then we have x to the times x to the 6n plus 2. All right, and that is my antiderivative. So now, I think I can get it now. All right, this up here should be equal to this evaluated at 0 and 1. You have to subtract. I do not have to take into account the constant whenever I do definite integral. So I'm just going to write, this is the sum n equals 0 to infinity, negative 1 to the n times 1 over 2n factorial times 1 over 6n plus 2 times x to the 6n plus 2 evaluated 0 and 1. Now let's actually figure out what happens when we plug in 0. When we plug 0 in, it doesn't matter. Plugging in 0 into this is going to be 0 and everything else doesn't matter. So really what I want to do is just plug 1 into this and figure out what happens. So this is going to become sum n equals 0 to infinity of negative 1 to the n times 1 over 2n factorial times 1 over 6n plus 2, and then times 1 to any power is just 1, so this is just 1. So that's what I would get when I plugged in 1, and then of course I would say minus, and when I plug in 0 we get nothing. So that's it right there, and I can even take that away. And now let me just figure out what this sum is. So this is actually, let's plug in 0 first. So when we go 0 here, negative 1 to the 0 is 1, so I get 1 times 1 over, I'm plugging in 0 here, so I get 2 times 0 is 0, 0 factorial is 1, so I get a 1 here, times 1 over, this is 0 times 6, so I just get 1/2 right there. Okay, that's my first term. Now I plug in 1. When I plug in 1, I get a negative 1, so minus. Plug in 1 in here, I get 1 over 2 factorial. Plug 1 in right here, I get 1 over 8. And let me just verify that this is, yeah, okay, this is working. Next one, I plug in n is 2. Negative 1 squared is positive, so we get plus. So this is an alternating series. Then I get 1 over, when I plug, where am I at? I plugged in 0, 1, now I'm plugging in 2. So that's going to be 4 factorial times, when I plug in 2 here, 12, I get 14. And then the next one, we're going to get a minus this time. I get 1 over, I'm plugging in 3, so I get 6 factorial times 1 over, let's see, 3 here, I get 18 plus 2 is 20. And I will keep doing this, and I need to know when I will be correct to 3 decimal places. So I'm going to need my calculator, and I actually don't know if I brought it. I did. Okay. So this is, all right. This right here is 1/2, so this is 0.5 minus. Okay, this is just going to be 1/16, right? So 0.0625, and then plus here I've got to do 4 factorial. 1 over 4 factorial, and then times 1/14, and I'm getting 0.002976. That's 19. Okay, that's good enough. And then minus, now this one, okay, 1 over 6 factorial times 1 over 20. This one is 0.000, there's 4 zeros, 0694. And we can stop here, and the reason we can stop here is because we had that alternating series estimation theorem earlier that said that the true sum, the difference between the true sum and our approximation is always less than the n plus 1 term. So in other words, if we look at how big this next term is, we notice that the first 3 decimal places are zeros. So every term after this is going to be even smaller than this. So it should have no impact on the first 3 decimal places. See, this one, the first 3 decimal places weren't zeros. So we couldn't stop at the previous one because the next term actually impacted that 3rd decimal place. But from here on out, there's going to be no impact. So we are good to just sum up to these first ones right here. If we just add these up, that should be approximated to 3 decimal places. So 0.5 minus 0.0625 plus 0.00297. I'm getting approximately 0.440 and then 47. So I know the first 3 decimal places are accurate. So my approximation really is just 0.440. 0.440. All right, I got a text or something here. Let me check this. That's good. Let's look at number 55. So number 55, you get y equals e to the negative x squared and then cosine x. And the instructions here are to use multiplication or division of power series to find the first 3 non-zero terms of the Maclaurin series for each of the following functions. So what we're going to do is use our table of Maclaurin series to rewrite these 2 functions, right? This right here and this right here both have Maclaurin series. We're going to go ahead and write the Maclaurin series for these down, then we're going to multiply them out. And so the Maclaurin series for e to the negative x squared will be sum n equals 0 to infinity. And then we have the formula is x to the n over n factorial. Again, this is page 484. X to the n over n factorial, but here we don't have, our x is actually negative x squared. So it's going to be negative x squared to the n over n factorial, that's e to the negative x squared, times another Maclaurin series, sum n equals 0 to infinity, cosine x, we just did that one, that's negative 1 to the n times 1 over 2n factorial x to the 2n. Now to multiply these, probably the best approach would be to write out the first few terms of this one, then the first few terms of this one, and then do kind of like an expansion. So this right here, let's start with 0. If n is 0, anything to the 0 is 1, so we just get 1 over 0 factorial, we just get 1. Then we plug in 1 for n. If we plug in 1, this is just going to become negative x squared to the 1, which is just negative x squared over n factorial. So, over 1 factorial, which is 1. So we should just get negative x squared. Now when we let n be 2, we're going to square this. So when we square that, the negative becomes positive. When we square x squared, it becomes x to the 4th. So we'll have x to the 4th over 2 factorial, which is just 2. So plus, I'm going to write it this way, 1 half x to the 4th. That's the same as x to the 4th over 2 factorial. The next one should be a minus because we're raising it to the 3rd power. So this to the 3rd power is a negative, but then x squared cubed is x to the 6th over 3 factorial. 3 factorial is 6. So 1/6 x to the, what did we say, 6? Now we plug in 4. So we plugged in n is 1, or sorry, n is 0, 1, 2, 3, now n is 4. We should get a positive because we're raising negative to a even power. And then x squared to the 4th is x to the 8th. So I know I'm going to have an x to the 8th. And then it's 1 over 4 factorial, which is 1/24. And this is going to keep going, right? The next one will be minus, but I'm just going to say dot, dot, dot. I'm hoping that that's enough, that's going to be enough for me to get the first 3 terms when I multiply these together. That times now the expansion here of cosine. So when we expand cosine out, let n be 0. This is going to be 1. We're going to get 1 here, and we're going to get 1 there. So it's going to be 1, and then it alternates minus 1 over 2x squared. The next one will be plus 1 over, this one is 4 factorial. And so you have to actually go back in your notes and see it. And also on the table, if you look at the table, it actually does this for you. It shows you the first few. This one is 1 over 4 factorial. 4 factorial is 24, and then x to the 4th. Next one will be 1 over 6 factorial. So 6 factorial, x to the 6th, and then plus, and it continues, right? So that's what I have. Now I multiply them together. So I'm going to start with this 1, and that 1 will distribute here. The 1 will go here. The 1 will go here. And so basically, because it's a 1, it's just going to repeat this whole thing. So the way I like to write this is I'm just going to write this down again, and I'm going to leave spaces for any terms that may appear in the middle. So right now I don't have any odd terms, but here, I don't have odd ones here either, but I'm going to leave spaces anyway just to be safe. All right, so I have 1, and then I have minus 1 half x squared, and then plus 1/24 x to the 4th, and then minus 1 over 6 factorial x to the 6th, and then it keeps going, but I don't really care. Now what I do is I move to the next term, negative x squared, and I'm going to multiply negative x squared through to each one of these. So go through all of them. So if I take negative x squared and I multiply it times 1, I get just negative x squared. So I'm going to line that up right here. I'm going to put negative x squared. Now if I do negative x squared times negative 1/2 x squared, 2 negatives become positive. I should get positive 1/2 x to the 4th. Positive 1/2 x to the 4th. And then let me do another one. This times this. So I'm going to get a negative this time. And it's going to be negative 1/24 x to the 6th. And I don't think I'll go anymore. I don't think I'm going to need any more. Because remember, all I want is the first 3 terms, and it looks like I'll be able to get them from here. But let me go and multiply out one more of these. So I'll just do this one here. This one gets passed through each of those. So 1/2 x to the 4th times 1 is 1/2 x to the 4th. And then 1/2 x to the 4th times this is negative 1/4 x to the 6th. Negative 1/4 x to the 6th. And then I could keep going, but again, I think I only need these. Let me just see, if I did one more, this one times 1 would give me an x to the 6th over here. If I did this one through, I would get x to the 8th, I'd be over here. So pretty much, as I continue multiplying through now, nothing is going to impact these first three terms. These first three terms are pretty much stuck, they're fixed. So I can say that this is equal to, I'm just going to add down, this is 1. When I add this down, you have negative 1/2 minus 1, that should give us minus 3/2 x squared. And then we have a half plus a half, that's 1. 1 plus 1/24 is 25/24. So I should get plus 25/24 x to the 4th. And then plus, it's going to continue. I could put these together, but I'm not going to because I was missing some things that would have appeared down here. But we only want this accurate to the first three terms. So let me double check that I did everything right here. Looks good. Okay. All right, so that's how you do number 55. Let's take a look at number 56. Y equals secant x. Now that looks pretty, I guess, it doesn't look very intimidating, right? It's just secant x, so you kind of like no big deal, but we don't have a Maclaurin series for secant x. What we do have is a Maclaurin series for cosine x, and remember secant x is 1 over cosine x. So this is really just 1 divided by this infinite series, n equals 0 to infinity, negative 1 to the n times 1 over 2n factorial, x to the 2n, all right? Which is really just 1 divided by, and then let me just write out the first few terms of the Maclaurin here. 1 minus 1/2 x squared plus 1 over 4 factorial. 4 factorial is 24, x to the 4th, minus 1 over 6 factorial, right? 720, just want to confirm here because I don't want to get through all this and then have a problem. And then it keeps going, right? So how do we take this and divide an infinite polynomial into the number 1? Well, this is where we have to do long division. All right, so I'm going to set up my long division. I think I'm going to just rewrite everything here. Just start again. Okay, so here's my long division. I have 1 inside, and on the outside, I have 1 minus 1/2 x squared plus 1/24 x to the 4th minus 1 over 720 x to the 6th plus dot, dot, dot. And now I start asking myself this question. What do I multiply 1 by to get 1? So just 1. So I put 1 up here. And now I multiply 1 through to this and then put that answer here and then subtract it. So I'm going to go 1 times 1. So I'm really just going to rewrite everything there. 1. I'm also going to leave some spaces here just in case I get some odd powers. 1/2, negative 1/2 x squared plus 1 over 24 x to the 4th minus 1 over 720 x to the 6th. And it keeps going, but I'm going to stop there. Now we come through and we subtract this row. So when we subtract the row, the signs change. This becomes minus, this becomes plus. I don't have my watch. This becomes minus, this becomes plus, and we add down. So the 1's go away, and then right here, I'm going to get a positive 1/2 x squared. Here a minus 1/24 x to the 4th. Here a plus 1 over 720 x to the 6th. And it keeps going. But I have 1 term. See, I'm supposed to get this to 3 terms. I have 1 of them so far. Now, ask myself the question again. What do I multiply 1 by to get 1/2 x squared? Well, just 1/2 x squared. So plus 1/2 x squared. and then multiply this through. 1/2 x squared times 1 gives me 1/2 x squared. I put it right under here, under the x squareds. And now things are going to get a little weird. 1/2 x squared times negative 1/2 x squared is negative 1/4 x to the 4th. So negative 1/4 x to the 4th. And then if I do 1/2 x squared times 1/24 x to the 4th, I should get 1/48 x to the 6th, positive. 1/48 x to the 6th. And then I can keep going, but I'm going to stop there. I come through and I subtract the row, which changes the sign. So that's minus, this becomes plus, and this becomes a big old minus. And now I add down, so these go away. My bet is this is just junk. Hello?
Good morning. Is Robert there?
Yes.
Hi, Robert. My name is Pamela. I'm with Dental Family.
Okay, that was actually a real call. All right, so these are going to go away, and then here we have to actually put these together. So I'm going to cheat because I don't feel like doing any math this morning. Negative 1/24, and then we're going to add a 4th. Oh my gosh, I'm ashamed of myself that I don't want to do that. That's negative 7/24 x to the 4th, and then when we put these together, I'm going to do 1 over 720. And I'm subtracting from that 1 over 48. And I should get negative 7 over 360 x to the 6th. So it's just adding, subtracting fractions, which I'm just being lazy here. I don't want to do it. Shoot. My batteries just fell out. That was a sign from the math gods that I should be doing that arithmetic by hand. Okay. Done. Keep it going now. I only have 2. I need the first 3. So I've got to turn 1 into this. So I'm going to put negative 7 over 24 x to the 4th. And then I would proceed through and multiply through and come through and then subtract. But I'm actually going to stop there and not do that work because all it asked for was for the first 3 terms, right? It did say 3? First 3 non-zero terms, so here they are. And double check my answer here. Whoa, what did I do wrong here? Minus, this is 1/2 minus 1/24, and then minus 1/4, it became plus 5/24. Hold a second here. Did I type that in wrong? Oh, I did type that in wrong. Oops. Why don't I just do the arithmetic? I accidentally did this minus this. See, that's what happens when you're not paying attention. Yeah, when you add these together, you get positive 5/24. Robert, you should be ashamed of yourself. Okay, so, and then this one, I think that one's right. What that does is when we came through with that last one and we did 1 times this should be positive 5/24. Okay. That's it. Sorry about that. All right, number 57. We have y equals x over sine x. So we do have a power series, a Maclaurin series for sine. So this is the same as x over. Now the Maclaurin series for sine, again on page 484, we're going to have x minus 1 over 3 factorial. I'll write it out as factorials first. X to the 3rd plus 1 over 5 factorial x to the 5th minus 1 over 7 factorial x to the 7th plus dot, dot, dot. And now when we do our division, we're going to need to have x inside the division box instead of a 1. So I'm just going to rewrite it all now. And let me cheat here because I don't want to have to rewrite all this. Here's my division box. X is going to be inside. And I'm going to just take this out. So that's what we're trying to do. So first question we ask is what does it take to turn x into x? And that's just going to be 1. Okay, so that's just going to be 1 here. And then we multiply through. So when we multiply through, we get x, and then we get minus 1/6 x cubed plus, double checking here, 1 over 120 x to the 5th, and then minus, oh, they don't even go that far. So I'm just, let me do 7 factorial. So 1 over 5040 x to the 7th plus dot, dot, dot. We come through and we subtract this row. When we subtract this row, this becomes minus, this becomes plus, this becomes minus, this becomes plus, and then we add straight down. And when we add straight down, those are gone, and we get 1/6 x cubed minus 1/120th x to the 5th plus 1 over 5040 x to the 7th dot, dot, dot. And now we need to turn x into, oh, and I didn't leave spaces, and I knew that was going to come back to haunt me. Let's see how this works out. I'm going to turn x into 1/6 x cubed. I need to multiply that by 1/6 x squared because the x squared hits the x, becomes x cubed. So that's what I'm going to multiply by. Now this is still going to work. Okay. So that times that gives me this right here, 1/6 x cubed. And then this times this, remember this is really 6. This is really 120. So when I take 1/6 x squared times 1/6 x cubed, I should get 1/36, negative 1/36 x to the 5th. And then the rest I'm not going to do because I have 2 terms already. I just need to figure out what happens on this next step, and this is all I'm going to need because these are going to cancel. So the rest of it is irrelevant. Good thing they're not asking for the first 4 terms. So come through, subtract. That changes to plus, and then who cares? And now those 2 go away, and I need to do those. So I'm going to do negative 1 over 120 plus 1/36. And I should get 7 over 360 x to the 5th plus some other stuff here, who cares? And now what I need to do is turn this x into this. So this is going to become, I need a positive 7 over 360, but x to the 4th, because I need an x to the 5th, and I have an x out here already. So I multiply that through. I should be good. And that's it. These are the first 3 terms right here. Okay. Do I have another one I have to do? 58. 58 looks kind of interesting. I don't know if y'all can hear this on the microphone, but the classroom next to me right now sounds like they're having a party. There's music and who knows, margarita machine. They're not having as much fun as I am, that's for sure. Y equals e to the x. Natural log times natural log of 1 plus x. So we have a Maclaurin series for both of these, again on page 484. So let me just write these out. We know the one for e to the x. This is going to be 1 plus x plus 1 over 2x squared plus 1 over 3. This was 2 factorial, but I'm just putting 2. 3 factorial is 6x cubed plus dot, dot, dot. And then we have the Maclaurin series for natural log of 1 plus x. So we didn't use this one that much in class, but it's here x minus x squared over 2. And then it's going to be plus x cubed over 3. And those aren't factorials. Minus x to the 4th over 4 plus dot, dot, dot. And now we just expand this out. So we only need the first 3 terms. So when I multiply 1 times this, I just get that. And I am going to, I don't need to put any spaces because all the powers are already accounted for. Okay, that should be good. That's 1 getting passed through there. Now x goes through here. So x times x is x squared. I'm going to put that here. X times this is going to be negative 1/2 x cubed. And so the next one will be this one, but it'll be x to the 4th instead. So plus 1/3 x to the 4th plus dot, dot, dot. And now I take this one and multiply that one through. And I'm going to get a 1/2 x cubed. I'll put that with my x cubed, so plus 1/2 x cubed. And then the next one is going to be minus 1/4 x to the 4th. And then my next one, who cares what it is, because these powers are getting too high. Now I'll take the next one and pass it through, this one to this one. I get a 1/6 x to the 4th. And this really isn't going to matter anymore because I only want my first 3 terms, so I don't care about all this stuff. And as I go out further now, the powers on x are higher than 3, so I know that nothing's going to change here. So I just got to put these together. So x, half of an x plus half an x squared plus x squared, that's just going to be 1/2 x squared. And then this one, I have 1/3 minus 1/2 plus 1/2. These two go away. We should just get 1/3 there. X cubed. And then whatever else is there, dot, dot, dot. So double check this answer here. Whoa. Yeah. Okay, that's it right there. Okay, that does it. That wraps up the homework there for 8-7.